Hello and welcome to this Controlsoft 4th generation iNet controller overview. In this video we will look at all the key components of the iNet 1-door and 2-door controllers. This will help you to understand the control unit's components and how it can be wired to work alongside the identity access software. Some of the key features of the iNet door controller are as follows. Both the 1-door and 2-door controllers allow for 2 Wiegand readers. The 1-door controller allows for a maximum of 2 OSDP or RS485 readers. The 2-door controller can be used with up to 8 OSDP or RS485 readers. The 1-door controller can be configured with 1 reader in and out. The 2-door controller can be configured with 2 doors with Wiegand readers or 1 door with Wiegand in and out readers. However, it can be expanded to control up to 4 doors when using either OSDP or RS485 readers. Both controllers connect back to the identity access software via TCP/IP. The 1-door controller has 5 inputs, whereas the 2-door controller has 9 inputs. These are designed to be used for request to exit buttons, door contacts, power supply faults, tampers, fire alarm monitoring or emergency release monitoring. If either 1 DRACU or 2 DRACU variants are ordered, power fault, battery fault and the tamper are pre-wired to speed up installation. The inputs are fully programmable within the identity access software. Both the 1-door and 2-door controllers have one output allocated for a lock, and a second output allocated for an auxiliary output such as a door alarm. Therefore the 1-door has 2 outputs and the 2-door has 4 outputs. The 2-door controller can have 4 locks connected to these outputs when using OSDP or RS485 readers. Both controllers have 2 RS485 ports for downstream system expansion. iNet to iNet expansion can have a mixture of 1-door and 2-door controllers, as well as previous generations of iNet door controllers. So let's now look at the iNet controller in more detail. 12 volts DC should be applied to the connector block labeled controller. To the left of this is a power LED. When lit, the unit has detected it has 12 volts applied. New to the version 4-door controllers is a dedicated 12-volt output, making it easier to remove power to the locks when configuring or working on the controllers. When the unit is powered and is operational, the UIO light will be flashing. This means the controller has booted and is ready. If the UIO light is not flashing, the controller may still be in its boot up sequence. Boot up normally takes between 30 to 60 seconds. If after this time the UIO light does not flash, there may be an internal operating system fault. In the first instance, a simple power cycle may suffice. All iNet controllers come with 2 RS485 ports. Port A connects with input-output expansion boards, OSDP readers, Aperia wireless locks as well as other legacy non-intelligent devices. Port B is used solely for iNet to iNet expansion. This is distributed intelligence, therefore the downstream iNets have the ability to work independently from the master, in case of communication issues. The RS485 network needs to be wired in a daisy chain topology. This means there is a device at the start and one at the end of the line. You should not spur off of a daisy chain, otherwise there will be communication issues between the master and the downstream devices. All RS485 communications should be wired in Belden 8723 or equivalent cabling. When the RS485 network is up, you should see the indicators flashing red and green. Red signifies transmit, and green signifies receive. The RS485 network can comprise of 4th generation 1 and 2 door controllers, as well as older generation iNet door controllers, as shown in the image by the version 3 controller. It is recommended that the master controller is a 4th generation controller due to an updated processor. An iNet controller can be addressed using the rotary switch labeled 1 to 8 and A to F. A to F signifies addresses 10 to 15 in a hexadecimal format. The iNet that has a TCP/IP connection is known as the master controller. The master controller should always be set to RS485 address 0. Downstream devices can therefore be addressed 1 to 15. You can have a maximum of 32 doors per RS485 network. The iNet controller has a set of 4-way option switches. This is used to select the following. Switch 1 selects between Wiegand Readers enabled or disabled. Switch 2 selects between RS485 port A or port B. Switches 3 and 4 are both reserved for future uses and should remain in the off position. Out of the box, switches 1 and 2 are in the on position, enabling Wiegand Readers and RS485 port B for iNet to iNet expansion. The iNet's 2-way bootloader switches are located just above the option switches. This is pre-configured and should not be changed. Changing the bootloader switches will result in the iNet's operating system not loading. If the switches are changed, down-power the controller, change the switches back to switch 1 off, switch 2 on, and re-power the controller. RS485 should be terminated if the network exceeds 100 meters, or 300 feet. This can be achieved by turning on the 2-way dip switch located above the RS485 ports. OSDP readers use the same daisy chain topology. The difference here is that power is normally sent on the same cable, therefore a Belden 8723 is ideal as you can use all 4 cores for power and data. Always use one pair for power and the separate pair for the data. Connect the shield through at each reader to maintain integrity. Terminate the shield to 0 volts on the controller. OSDP can run up to 1000 meters, however on longer runs a power supply may be required locally to the readers due to voltage drop. Wiegand readers are connected to the 8-way terminals. They should be connected using a Belden 9538 or equivalent cable. A Belden 9538 is an 8-core cable with an overall screen. The readers can operate to 80 meters, however if used over 25 meters a local 12-volt power supply will be required. Shown on screen are the wiring colors for HID readers. However other manufacturers may use different color coding. Power and data are the only mandatory connections, however it is advisable to use all available to improve the end-user experience. It is important to note that you cannot use both Wiegand readers and OSDP readers on the same iNet controller. It should be planned before installation what reader type is going to be used, as cable types are different between Wiegand and OSDP readers. The relay outputs are located above the reader ports. These are used to connect a lock or auxiliary device. An example of an auxiliary device would be a local door alarm to advise the user a door has been left open. In this example we show how to wire a fail-safe electronic lock through a double-pole emergency release, and where to terminate the lock on the iNet. Take the 12-volt for the lock and wire into the normally closed terminal on the first side of the double-pole emergency release. From the common on the same side, wire into plus 12-volt on the lock connector on the iNet. Wire from the 0-volt for the lock to the normally closed on the second side of the emergency release. From the common on the same side, wire to the normally closed on the iNet relay output. From the common on the iNet relay output, wire a link to the 0 volts on the lock connector. This will create a normally closed circuit all the way through to the electronic lock, therefore 12 volts will be provided continuously through normal locking operation. When the relay switches, 12 volts will be disconnected and the door will release. If the emergency release is pressed, both sides of the 12 volts will be disconnected. Please note the MOV that is fitted between both lock connections. These are provided with all controllers and should be fitted to stop any electromotive force, EMF, from reaching the controller and damaging the circuitry. Failing to fit will result in voiding warranty of the iNet controller. The inputs can be located on the left-hand edge of the controller. These are labeled 0 to 4 on a 1-door controller, and 0 to 8 on a 2-door controller. The iNet controller's cover shows recommendations on where to terminate each input type. For door 1, on either a 1-door or 2-door controller, the cover recommends wiring the request to exit button and door contact into input 0 and input 1. On the 2-door controller, the cover advises to plug in door 2's request to exit to input 2 and door contact into input 3. These are the defaults when the door wizard is used in the identity access software, and are designed to make configuration easier. However, as the inputs are fully programmable, you can wire to any available input and configure its action in the software. When an input is activated, the input light will illuminate as shown in the image. Power supply fault inputs can be wired into input 3 on the 1-door controller or input 5 on the 2-door controller. There is a dedicated battery fault input on the 2-door controller on input 7. As explained earlier, these inputs are recommendations. They can be reused for other actions if required. If 1 DRACU or 2 DRACU variants are ordered, the fault inputs will come pre-wired. A tamper can be wired into input 4 on a 1-door controller or input 6 on a 2-door controller. If 1 DRACU or 2 DRACU are ordered, the box lid and back tamper will come pre-wired. On a 2-door controller, input 4 is designed for fire alarm monitoring. This is designed to be used with Identity Access Professional or Enterprise, to provide fire alarm roll call reports. It is not recommended to use this input as a fire alarm release. Finally, there is a spare input. On a 1-door controller this is input 2 and on a 2-door controller this is input 8. These are designed to be used alongside actions and events with Identity Access Professional or Enterprise. For TCP/IP connections to the iNet, a RJ45 port can be found located in the top left corner. Out-of-the-box iNet controllers are configured for DHCP. To reset the IP address of the iNet controller to a static IP address, a reset button can be located at the top of the board. Press and hold for approximately 7 seconds, until the reset light flashes on and off. The IP address of the controller will now be 10.0.1.230. Thank you for watching this technical overview on the 4th generation iNet controllers.